Okay, we're just going to go ahead and get just a real brief video here at low water level of the Nova project. We had a witness test, demonstrated everything. We're going to go ahead and show you here just a couple of features. So in this case here, we had two things we recommended. We recommended curtain walls in the front, eliminated any surface vortex activity, took care of all that. And then we've also recommended flow conditioning baskets. So these baskets here actually clean everything up right at the pump itself. So we'll put a little bit of dye in here, and you see that pre-swirl is very low. So a vortex can still form. You look right there, go to the side. Look right there on the side, see how it stays completely attached? So it completely eliminates any flow separation. And then underneath it, where we had strong floor vortex activity, you get a little swirl, but in the middle of the basket, that's all spread out in there. So this just dissipates everything within at the basket itself. So things can happen around the sides. Same thing on the top. Right here, it'll straighten it out at the basket itself. So that takes care of everything, cleans it all up right there at that point. So everything looks good. We've got data for all the different conditions, all that looks great. But the thing we want to show here that we didn't show during the video is we made a modification to the steps. So let's come up here and look at that. So we had a very high velocity at these screens right here. Lots of flow separation. We had to raise the water level to prevent a choke flow condition. So this step was incorporated across the width here. This significantly improved conditions at the screens. We've actually got some screens simulated here. You'll look at them, the wire mesh on there. We just go across the front of it here, and it's just much more stable across the screen. We've measured velocities, they look a lot better. Over on the corner over there, you're still going to get some separation on a 90-degree corner like that right there. And you see it come across here like that a little bit, but if you go down in front of the screen, you'll get a little bit of a dead spot on the side there, but it's improved inside of the pump bay. Overall screens are a lot better across the width, just a little bit of stagnation on the sides. We don't have the real high velocity. So down below a little bit here, you see, again, a little separation in the corner. And then right here in front of it. Okay, so there we go. We go across the width, and you'll get, again, you get a little bit of non-uniformity across there, but it's all going through the pump. A little bit of the separation causes a little bit of that. And once you come up a little bit higher and in, which is hard to see because of the, right in this area here, it's hard to see because of the way the screen, we've actually got good screen flow. So just a few spots where it's a little bit non-uniform. And then in this over here, it looks a lot better all the way across. So there's an actual big improvement. We validated this with decent velocity profile. This looks really good. Everything's in criteria. It can operate down at the low water level that was originally designed, and it's going to be acceptable. All right, the last thing we're going to show in just a second on the video, we had a request to raise this cooling tower floor level by a little over 6 inches prototype. So we're going to go ahead and put a false floor across the end of it here, and we're going to find out whether we get any sort of a choke flow condition, and then we'll determine whether that's going to be acceptable or if we have to have a change in water level. Okay, last thing we did here was simulate this floor coming up 6 inches. There's two ways you can do it. We could drop the water level, or we could bring the bottom up. We chose to bring the bottom up enough upstream here so that it allowed normal depth to establish itself over it. And it's fine. We're not choking. We've got because it's across the whole width here and not right there at that narrow area, we're not hitting critical flow. So it doesn't change anything we're recommending down here. It's just a slight bit faster over the top of that, but we've got enough of a distance between them that we're not having an influence down here. So this looks a lot better than it did originally without that step. This is, again, still at low water level. If it operates up at normal or at a higher level, it'll further reduce the screen velocities, which will just make it easier to get them in and out. But in terms of the pump, everything looks good back here.